Bharot sir, please begin.
Yes, yes, sir. Thank you. Good afternoon, all. I welcome Mr. Bhavik, who is from Courier eSolution LLP, as a today's webinar expert on the topic of manufacturing with Mastercam. He has total of 7 to 8 years of experience uh, in this domain, and he has provided many online trainings as well as solutions based on that actual software oriented requirement. So without wasting time, I request Bhavik sir to start the session. Bhavik sir.
Thank you so much. I hope my screen is visible, and I'm
Yes
also
sir.
audible.
Yes sir.
Okay.
Yes sir.
Good afternoon, everyone. I welcome you from Cad Solutions LLP in this webinar, which is based on manufacturing with Mastercam. So, Mastercam is a proper CAM software. You have heard about CAD and CAM. So, CAD and CAM both are related to each other. So, Mastercam is properly set up for CAM environment. So after designing a particular model, we can export that model into Mastercam, and further toolpath and all that manufacturing related, all the processes will be there in the Mastercam. So we need to process that model further for manufacturing point of view, and it will have many facilities like turning, milling, mill turn, router, and all that machining related details. So let's begin with some basics. I would like to give some details regarding the gap between institutes and industries. So there are some details which you learn during your engineering, and after your engineering, you need to develop your skills regarding particular softwares like CAD software or CAM software to fulfill the actual industrial requirement. So we need to collaborate, gap is there between educational details and industrial details. So we need to narrow that gap, and it will be like the final output will be industry ready student. So as far as your engineering is concerned, obviously there are many subjects are there, but some details are there which is just you can get it afterwards. Let's say once you start doing a job in core field, you will realize that these details I need to learn. So that specific details are like manufacturing details, like programming, part programming, let's say CAD modeling, and machine related details and toolings. So before going to Mastercam, you need to develop some basic skills like CAD and basic knowledge of various CNC machines as well as various toolings. So that point I would wanted to discuss before the webinar. Similarly, nowadays we can see that many industries are accepting this CAM and CAD technology very well, and they are adapting it like anything. After filling the gap, you can also join it. You can also develop your skills regarding this CAD and CAM technology. There are various softwares available for CAD as well as CAM. So we'll have some details and we will see some details regarding this Mastercam. If I say about our organization was previously known as Korea CAD Center, which was established in 2013. Uh, for almost a decade, we have been serving in CAD CAM and CAE technology. We are also providing industrial project development, consultancy, training, software sales, and 3D printing, as well as virtual reality related details. So, into 2020, our organization has been renamed with Korea Resolutions LLP, which is also known as KES in short. We are believing in global concept. So, like think locally, work globally. That is global. Let's go further with that. Mastercam is a US based software company. Parent company is CNC Software Incorporation. Main product of this company is Mastercam. Mastercam is almost in market for let's say 38 years. Mark and Jack Summers developed this software in a very small scale, and it has almost completed 38 years in December 2021. They have, let's say, generated from very basic details, and at a very previous stage, Mastercam was in a, let's say, infant form. It has very lower details at initial stage, but year by year, day by day, they have improved the product, and they have incorporated various details regarding milling technologies like turning, milling, turn mill technology, and routing. Mastercam is one of the top CAM products worldwide. There are many other products also for CAM technology, let's say computer aided manufacturing technology, but it has topped all the products. Mastercam has topped all of them, and nowadays it is number one in NC programming throughout the globe. We can see many other softwares like NXCam, Creo Element, EdgeCam, Katia, SolidCam, and many other softwares. But Mastercam is one of the oldest, and it has been adopted globally through many industries like automobile industry, die mold design, plastic injection molding manufacturers, mold designers. Similarly, in aerospace, in as well as in all the sub branches of mechanical engineering, say, let's say mechatronics, electronics, and many other engineering disciplines have adopted Mastercam for their manufacturing needs. So, what are the capabilities of Mastercam? Mastercam has various machining capabilities. It can work upon milling, turning, router, wire EDM, as well as design solid models. Yes, Mastercam can also work in as a CAD software, but general scenario is like that. You need to develop a 3D model in any CAD software, and then you need to export it to Mastercam, and then after you need to give some details that will generate various tool paths, and ultimately it will give you output in G code and M code. So it will be like part programming. So main aim of this software is part programming, and many machines it supports from various machine manufacturers. We will have some details about it further. And who are using Mastercam? So some Indian companies as well as many MNCs are also using Mastercam. So we can see some private companies residing in India and using Mastercam as their prime product for part programming, like Tata Motors, L&T, Bajaj Auto, and many others. Similarly, in government sector, there are many units as well as establishments who are also using Mastercam as a prime product for their manufacturing needs, like DRDO units, ISRO, HAL, Railway Workshop, and BEL, Bharat Electronics Limited, and many other government establishments. There are several educational institutes also who are using Mastercam for their study as well as research purpose and fulfilling their programming need, like SVNIT Surat, Nirma, SVPIT, IIT Mumbai, IIT Guwahati, and many other institutes. Similarly, all government tool room training centers are also engaged with Mastercam, and they are also using this technology for many years. Here is a list of machines which can be collaborated with Mastercam, and you can work out with Mastercam for many controllers as well as details of axis configuration, like DMG Mori, Haas, Micron, Mazak, Mitsubishi, Monarch, and many other machine manufacturers are collaborated with Mastercam, and they have been using with collaboration of Mastercam. We need to develop a post processor to run a particular program output of Mastercam in that specific machine. So machine language and post processing language, that are kind of connectors. If I'm getting an output from Mastercam in G code and M code, you need to convert it further to be adopted by your machine. Let's say I'm having a Haas VF8 machine which has FANUC controller. Then you will have to convert that program according to your machine details, which will be provided by Mastercam. So there is a process called post processing or developing post processors, which will be enabled by machine manufacturer as well as Mastercam. So it will be like converting a common code into a specific code to run in that specific machine. So machine manufacturers as well as Mastercam both are working in collaboration for developing their projects. So what are the exact applications of Mastercam? Mastercam basically deals with milling process. Milling is a manufacturing process in which materials are removed through milling process through various toolings. So what will toolings do? It will cut the material from a specific depth to another depth, and ultimately it will develop a specific product through milling process. Similarly, turning can also be done through Mastercam. So it will be like a CNC lathe, CNC turning center, we can say in specific. CNC turning center, Mastercam can also work with CNC turning centers. So here are the applications like component machining, which I just discussed, fixture machining, die mold, design die mold, milling, sheet metal die and punches machining, insert machining, reverse engineering, router machining, as well as jewelry, shields, and medals manufacturing. So many other applications are also there, like EDM, wire cut can also be run through Mastercam. Even Mastercam have developed some details regarding robots. So even robot programming can also be done through Mastercam. In the industrial robots to be specific, like painting robot. So main function of this software is to work with CNC machining. CNC machining includes both turning as well as milling. So here is the basic workflow through which we can generate programs in Mastercam. First, we need to develop a CAD model, which can be developed in any CAD software. I'm repeating, in any CAD software. Yes, Mastercam adopts most of the CAD formats. So you just need to generate a CAD model in CAD software, then import it to Mastercam, then generate various toolpaths according to your need, simulate it and verify if there is any details that need to be refined or tuned. Just do it, and then it will generate NC program. NC program stands for numerical control program. So it will be generating various codes in G code and M code format and transfer it to your CNC machine through post processing. So this is the basic workflow through which we can generate programs for milling as well as turning operation. Another details are given, like first you design CAD geometry, then export it to Mastercam, work out through various toolings and various toolpath details, give feeds, speeds, and cutter related details, and it will generate output in NC program, so numerical control program. Even Mastercam can also deal with some solid models as well as it can create solid geometries also. As I said earlier, it supports many CAD formats. Like you can work out with your CAD model in any of the softwares like SolidWorks, Solid Edge, Rhino, AutoCAD, 3D, and many other softwares, as well as Creo, NX, many other softwares. You can just transfer it to Mastercam, and you need to work further in Mastercam for developing their program output. So here are the translators, or let's say file formats, or we can say file extensions, which are compatible with Mastercam. So you can just leverage Mastercam with data translators. So these are the file formats actually. Let's say IGS, Parasolid format, SAT format, AutoCAD formats like DXF and DFG, as well as Inventor TM format files. It can also work with SolidWorks format file formats, Solid Edge, step file mesh, step format, STL, VDA, and many other formats. It can also work with CATIA Pro E, which has now become Creo, in many other formats Mastercam supports. So that is a flexible uh, point of view, we can say that Mastercam can accept all of these formats, any of the formats. You just name it and it will be working with Mastercam. So that is the main detail about Mastercam, that it can adopt any CAD format, any CAD specific file extension. So this was the basic details regarding the software. Now we will work throughout the software. I am going with changing my screen to the software. I hope my screen has been updated. Let me know if it is showing Mastercam.
Yes, sir, it is visible.
Okay. So here is the main screen of Mastercam. We can see user interface is like CAD software, like any CAD software, which in which we can have WCS, World Coordinate System. Apart from it, Mastercam has some toolpaths, some toolings, and details regarding simulation and verification. So first of all, we need to generate a CAD model through a CAD software. Then we can open it from file. Let's say I'm opening it from a file. So I have generated this part in SolidWorks, which now I am opening in Mastercam. So we can manufacture this part through Mastercam. I have developed several details, so we'll go, work through it. For milling purpose, we need to specify that which milling process we need to work with. Let's say I am going to work with machine, select your machine. I'm going with milling. In manage list, we can see various post processors. If I'm having a specific machine, let's say Haas VF8 model, then I will have to install that post processor, which will be given by Mastercam to me. And I just need to go through that specific machine detail. And then the program output which will be generated by Mastercam will run in that specific software. So at initial stage, we need to define in which machine we want to manufacture this particular product. After that, Mastercam will generate a program which will be adopted by that specific machine. So that will be a post processing process. So here the workflow is a bit different in case of Mastercam. We need to specify that post processor at earlier stage. While in other softwares, the workflow is kind of different. In other softwares of programming, we can work through this post processing at the end of the program. So Mastercam is working in different manner. I'm going with some sample details. So here is the details of multiple toolpaths. Let's say this is our CAD model. This is the final product we want to manufacture with Mastercam. So you just need to develop that CAD model and specify your blank part. Blank part will be like I can explain in a other manner. Let's say if you are manufacturing gears, then you need to have a gear blank, which will be like a disc only. So that gear blanks will be inserted, and then gradually teeth will be milling. Teeth will be generated through milling, say hobbing cutter. So it will be generating from a blank part. So in this manner, in Mastercam also we need to define a blank part like this. So here is my main blank part, which I have defined, and software will generate by the final product by removing material from this blank part. So here is the final product which we need to develop through various toolpaths. I have developed multiple toolpaths over here. like milling this extra material, then working through this pocket, then another pocket, and many other pockets. Many even drilling operations are also there. So almost 24 different tool paths are generated. We need to specify each and every details, like which tool we want to use for milling this, let's say pocket, which tool we need to use for drilling this hole. So that is very specific. Selection of tooling should be very specific and accurate. So it will ultimately save your time. While using Mastercam, main goal is to achieve shortest toolpath, and it should be completed in very small time. If the time will be higher, let's say cycle time, it is specifically known as cycle time. If cycle time is higher, then it will be difficult. It will be difficult to mass manufacturing. Let's say if you are working in a manufacturing company which are using Mastercam, but if you generate a program which is having a high amount of toolpaths and various details, which is ultimately lengthening the cycle time. So you just need to shorten it by adjusting many parameters. Tooling selection is the main thing. Tooling selection as well as feed and speed, cutter details, depth of cut, and many other parameters which are uh, in calculation, which can be affecting the time, total cycle time. So we can have some details through simulation. I'm selecting all these toolpaths, so it will be showing me that all the toolpaths are selected. We can visualize this. We can visualize it through the screen. In simulation option, we just need to go through simulation environment. So I'm verifying this. It will generate simulation data. And a new window will be opened. I'm switching the window. So this will be the simulation window. We will have various details like total time. We can see in the lower right corner, total time is showing like 11 minutes and 30 seconds. It will be like a total time which will be taken by this complete tool path. I'm playing it. See, it is the blank part from which we are going to produce a final product. So I'm simulating this detail. Making it slow so we can have some details. So here is the tool which is gradually removing material. So after completion of this all operations, we can see the finished product. Sequence are set like roughing, semi-finishing and finishing. We need to give all the details like which tool we want to use for roughing, which tool we want to use for semi-finishing, and which tool we want to use for final finishing of the product. So it will eventually work through that sequences and generate the final finished product. So here we can see that it has removed material from that blank part through some sequences as well as various toolings. Like here, it has generated a pocket, here another pocket, here a slot has been created, and other open pockets are also there, which is having various depths. Like this pocket is having highest depth, this one. Then inside that pocket, there is also a pocket inside the pocket. Similarly, here various types of holes are there. Let's say counter bore hole, counter sink and counter bore, and simple hole, straight hole. And here a hole with counter sink as well as counter bore details. So all of these tool parts are generated, and we can see total cycle time is showing 11 minutes and almost 30 seconds. So what will be after this process? If there is a collision during the milling process, we can also check. Let's say we can give details in stopping condition like collision. So if there is any collision during the entire milling process, it will be showing a warning in form of collision report in this detail, very top corner, right top corner, collision report. If you want to play the simulation again, you can just go to this start condition and it will be like blank model again. So I have now enabled collision detection, and now I'm also again playing this. If there will be any collision, then it will be there in collision report, and simulation will be stopped at that particular point. So we can work upon it, and we can fine tune that why collision is happening, what is the details that need to be refined. So there is no collision, so it is not showing any collision report. But if there is any collision during the milling process, it will be stopped and details will be there in this collision report. After this simulation, we need to give this as a output program, as an output. So for that, I'm moving back to the main screen. Hope my screen is visible. So we are back in that main screen. After verification, we just need to post all these toolpaths. So for that, we need to export it to this code expert. There is a module of Mastercam known as code expert. So I'm transferring all these toolpaths into that code expert. It will be asking me that which file you want in output. So there is a post-processed file which is known as .nc file. I'm going with that format. It will process it and ask me where to save that file. So I'm saving it, and you can even rename it also and save. So it will post process and new code expert window will be opened. Switching the screen to code expert. So here is the window of code expert, in which it has given all the details in form of NC code. So all the toolpaths are now uh, posted in a generic form. If we are having any specific machine, then it will be having slight different codes, like according to controller, which controller you are using, which machine configuration you are having. It will be generating according to that machine details. So that will be the final post processing details, which we need to give to a specific machine, and it will mill accordingly. So here is the code we can see right now, which has been generated by Mastercam. This file can also be opened in Notepad. So if you want to use some details, specific details, or you can edit it manually also. So this was the example, basic example. I am going to have another example, which will be like multi-axis example. This was for 3-axis milling. I am going with another model. Now going with 4-axis milling. So here we can see another blank part, which I have defined earlier. From that part, I just want to finish this product. So for these kind of products, we need another machine details like 4-axis rotary milling. So machine will be different for that. Previous example we have just seen was conducted through 3-axis machining, and parts like this we need to go with 3+1 configuration. Let's say 4-axis machine. So I am going to simulate this. It will be transferred in a simulation window. So part can be seen and simulating it right now. it is also showing total time of 7 minutes and 31 seconds. Playing it to simulation. So in this case, the tool is following the axis of the component. We can change it to rotary direction of rotation. We can change it to radial also. I'll show you how to change that. Now I'm changing the direction and making some changes in the main toolbar. Here I have used rotary 4-axis toolpath. I'm going to change the parameters from axial cut to rotary. Now changing it to rotary, applying it and OK. Now I need to regenerate the entire toolpath. So regenerating the toolpath. It will take some time. Okay, so now it has been regenerated and adjusted to rotary direction. Now simulating it again. We can see that time has deducted to 3 minutes and 10 seconds. Earlier it was like 7 minutes and 31 seconds. Now simulating this and verifying it, making it a bit slower so you can see details. So this will work as a rotary direction. So this was the rotary machining, or we can say rotary 4-axis rotary milling. Now going with another multi-axis sample. So here is a blade. There is a specific toolpath known as blade expert. We can generate various impeller blades through this toolpath. If I'm having a blank part like this, it will cutting these blades through the blank part. Here you can see the blank part is there, and here is the final product like this. So you just need to make a CAD model and then export it to Mastercam, specify blank shape, and then generate to toolpath with various details. So how will it work? This can only be done in a multi-axis machine, which is having configuration different than 3-axis machines. Simulation of this toolpath will be like uh, this. Post processing it in another window. So here is the blank part through which the blade will be cut. I'm adjusting some parameters to make the time shorter. Regenerating the toolpath. And simulation of that toolpath will be like this. So now it is showing almost 44 minutes and 10 seconds. I have adjusted feeds and speed of the tool, playing it. So it will be cutting like this. Similarly, all the blades will be cut through the same mechanism. So it will eventually generate all the details of that particular blade component. Okay, so this is it. The final blade has been created from a blank part. I hope I have explained some basic details which would be fruitful for you to understand basics of computer-aided manufacturing. So this was a particular software through which we have seen various details, Mastercam. Let me know if you have if you are having any questions.
Sir, one question will be there regarding tool wear. Actually, machining, which is performed on a machining center, either milling or turning or any reference example. But how much we are giving importance to tool wear? Tool wear.
Tool wear.
Yes, sir.
There is a parameter like cutter compensation. So it will deal with tool wear. If you are having a tool, let's say it is a standard diameter, outer diameter is 20, but after use of that tool for multiple times, it will be reduced to, let's say, 19.8. So we can compensate and we can adjust that tool diameter in Mastercam, that we can inform it. The tool diameter is standard diameter is 20, but due to wear, it has become like 19.8. So it will cut that particular part accordingly. It will understand that tool has worn out, so it will generate tool paths with that clearance. So yes, that can be addressed
Thank you
in
very
Mastercam.
yes. Thank you very much, sir, for the knowledge sharing session from your end on manufacturing with Mastercam.
Thank you,
And
sir.
we are grateful to you, sir, from our end for such a technical and in-depth session from your end,
Yes, sir.
which will try to include introduction, capability, application, and many examples which we have seen as a part of 4-axis milling and all that. So that will be
Yes,
there.
sir.
Thank you for, sir,
Yes, sir. Thank you. I have shared a feedback form
such a sharing session. Yes,
to
sir.
Bharat, sir.
It will be
Yeah,
done. Yes,
yeah,
sir. Once you share that link to me, I will be proceed for that particular reference.
sure.
Okay, sir. Thank you,
Okay.
sir.
Okay. Thank you all.